Hi guys, hi, welcome to Momentum with Vedantu. Welcome here. Oh my god, so many people are here in this class, huh? Oh, Pranuti is here, and once again, let me check. Yeah, so Pranuti is here, Muthu is here. Oh my god, Sam Niran is here. Sam Niran, hi, Vangampalli, Akshara Yadav, Fab Phoenix is here. Very good, very good. Surender Singh is definitely here, of course. Awesome, guys. Awesome, awesome. Welcome to Momentum with Vedantu, guys. Welcome to today's class. I unfortunately did not add the comments in the presentation. I unfortunately did not. Shri Balaji is also here. Superb, Shri Balaji. Hi, hi, hi. I unfortunately forgot to add the comments from the YouTube comment section to see who was in the Hall of Fame, but we'll talk about that. Okay, I'll talk about who is in the Hall of Fame in some time. Okay, no issues, guys. All right, so welcome to Momentum with Vedantu, guys. Superb, superb, superb. Let's start today's class as well. Today we are continuing with Ray Optics. This is probably going to be our second last lecture. We are talking about lens displacement method. Okay, it's a very important method because so many times JEE has asked questions on that, and it's an experiment that most of you are supposed to do in the lab, but for some reason nobody does. I don't know why you don't do that, but it is part of your curriculum. You're supposed to do that experiment in the lab, but you don't do. I don't know. Okay, so we'll study that today. We'll study that. Oh, Shri Balaji, the schools are opening in Tamil Nadu from October 1. Huh? Wow, wow. Be very careful. Okay, be very careful, Shri Balaji. Please don't go anywhere, guys, without a mask. Please stay away from your friends, and hopefully, the entire schools will stop, not catch corona. So scary out there. So scary out there. Oh, Leander is also here. Hi, Leander. Didn't know you also came. Okay, good, guys. Okay, awesome. So let's start. Okay, let's start. Sam Niran is saying that only for doubts clearing the schools are opening, otherwise the schools are not opening. Huh, I didn't know that. Okay, guys. So this is lens displacement method and combination of lenses part 1. Okay, we'll try to finish as much as we can today because this is a big topic, but let's understand. Okay, and understanding the lens displacement method is much more important than remembering the formulas, because if you understand the formulas are very easy, my friends. If you understand the formulas are very easy. Okay, all right, guys. So let's start this. Before we start, though, if you haven't liked, shared, or subscribed to our channel, please do that. Please like, share, or subscribe if you do that. Okay. Anyways, all right. Now, also at the same time, guys, I just want to tell you, if you are a repeater and you're preparing for JEE Mains and you want coaching from India's best, these people are India's best and they are on Vedantu. Okay, they have taught students at Allen Chandigarh. They are the top faculties from Allen Chandigarh. Okay, and they are on Vedantu just to teach you guys. You can learn from them. You have to go through the link in the description and get enrolled into the program. It has already started from 21st September, but there is one more batch which is going to start later this month. Okay, and you can use my promo code AAPPRO to get 20% discount. Okay, just in case you want to do it, guys. If you don't want to do it, you can come here as well for my lectures. Okay, no issue. Alright, guys, so let's do this. Let's do this. Uh, Lens displacement method. So first of all, it's an experiment, and you guys need to understand that it's an experiment. You have to do it in a lab. So think from that point of view. Okay, if you were doing this experiment in a lab, how would things go like? Okay, so what you do is in lens displacement method, guys. In lens displacement method, basically you try to calculate focal length of an unknown lens. In lens displacement method, you try to calculate focal length of an unknown lens. And how do you do that? How do you do that? So let me explain one by one. So first what you do is, now you do a setup like this. Okay, basically you keep an object here. Okay, you keep an object here, you keep a screen here. Okay, and you fix the distance between the object and the screen as distance d. Okay, object, screen, and distance t, all these things are fixed. None of these things can move now. Okay, none of these things can move. The screen is fixed, the object is fixed, the distance d is also fixed. Okay, now what you do, guys, now what you do is you keep the unknown lens in between the object and the screen. You keep the unknown lens somewhere in between the object and the screen. Okay, and you move this lens around in such a way, that you get a proper image of the, you get a sharp image of the object on this screen here. You move this lens around in such a way that you get a sharp image of this object on the screen. You move it till you get that. Okay, and let's say you got it at this position of lens. At this position of lens, what you got is you got a sharp image of the object on the screen. Then what you do is you move it again, because this is where things get interesting. Okay, yeah, oh, Sandaran has already done this. Okay, okay. So this is the first position of the lens. What you do now is very simple. What you do now is you move this lens around such that for one more position of the lens you get a sharp image. Okay, so you move it around, you moved it around to here, let's assume, and you again got a sharp image of the, you again got the sharp image of the object on the screen, sharp image on the screen. Okay, so there are basically two positions, this and this and this and this and this and this. For both these positions you get sharp image on the screen. Okay, for both these positions you get sharp image on the screen. I hope everybody understood. You are moving the lens, guys. Okay, I hope everybody is following. So now in this case, what you do is, let's say the distance between those two position of lenses, is small d. Okay, distance between those two position of lenses is small d. Now what exactly is, are there two lenses here? By the way, are there two lenses here? No, there is only one lens. These are two different positions of those lenses. Okay, there is only one lens here, guys. Please don't get confused. There is only one lens here. These are the two different position of the lenses. Okay, yes, the size of the image will be changing. Correct, the size of the image will be changing. We will talk about that as well, don't worry. Okay, so I have two different positions of the lenses for which I get the sharp image, and let's say the distance between those two positions is small d. Now I have to calculate the focal length of this lens in terms of what I know. So I know the value of capital D, I know the value of small d. Based on these two values, I want to calculate the focal length of the lens. So now guys, how do I do this? How do I calculate the value of focal length based on these two things? So in order to understand that, let's go back a little bit. Okay, let's go back a little bit and let's try to learn some theory. Okay, so what, let's say I just have an object and I just have a lens. Okay, and let's say in this case I get a sharp image here, object, lens and sharp image, object, lens and sharp image. And let's say the object and the image distance, I denote them by x and y. Okay, I don't want to write u and v because that confuses me a lot, so I'm going to write it as x and y. Okay, can you guys see this? X and y. The object distance is actually minus x, and the image distance is plus y. Okay, but these distances x and y. Now guys, remember this diagram. Okay. Now tell me what happens if I remove this object and image and I keep an object here. Tell me in the chat right now what will happen. Can you see this? Okay, if this was the case and I remove this object and image and put a new object here, where will the image be? Tell me in the chat right now. Nobody. Where will the image be? Image will be. Of course, the screen is missing. Shri Balaji, I will add the screen if it's necessary. But just right now, tell me the position, my friend. Just tell me the position. Screen I will add as per necessities later. Don't worry about it. Where will the image be? Just tell me the position of the image. Where will the image be? The image in that case will be at distance x. Okay, if see, this is very important. If I keep object at distance x and images at distance y, then in that case the reverse will also be true. If I keep an object at distance y, I will get an image at distance x. Okay, I hope you guys understood. I really hope you guys understood. Or a different way of saying that is that, oh, sorry, a different way of saying that is, one second, huh, guys? A different way of talking about it is that I can reverse the two. Okay, I can reverse the object. Oh my god, one second. La 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 la. La 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 la. One second, and one second. Yeah. One more way of talking about it is, let's go back now. Yeah. One more way of talking about this is that if I have an object at distance x, image is at distance y. If I have an image at object at distance y, image will be at distance x. That means if I do it like this and keep an object at distance y, there will be an image at distance x. Okay, if I keep it like this, keep an object at distance y, the image will be at distance x. Now guys, if you see this in all these cases, in this case and also at the same time in this case, in both these cases, in this case, one second, aja aja niche aja niche aja niche 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 zyada nahi zyada nahi. In both these cases, this case and this case, this case and this case, this case and this case, okay, in both these cases, what is remaining the same? What is remaining the same? The distance between the object and the image, the distance between the screen and the object always remains the same. Okay, and this is essentially what happens. This is essentially what happens in case of lens displacement method. This is essentially what happens in case of lens displacement method. The two position of lenses are going to look something like this. Guys, if you understood this, please give me a thumbs up in the chat so that I know you guys are following. If you understood this, please give me a thumbs up in the chat so that I know you guys are following. Okay. Alright, I don't know if you guys are following. Tell me if you follow. Hmm. Mm-mm. Nobody is following. Hmm. Nobody is following. Oh, Surender is following. Sri Balaji is following. Good, 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 good. Okay, two people are. Now, guys, if you look at this, it becomes very easy. It becomes very easy to see a few things. Okay, it becomes very easy to see a few things. If I talk about this, first thing you can say is that from this diagram, sir, first thing what you can say is that D, capital D, can be written as x plus y. Do you see that? Capital D can be written as x plus y. And also at the same time, small d can be written as y minus x. Small d can be written as y minus x. I don't know if you guys can see this. See, this entire distance is y and it's also x plus d. Okay, now from these two equations, if I solve for x and y from these two equations, guys, if I solve for x and y, what do I get? If I just add these two equations, I get d plus d is equal to 2y, or y is equal to d plus d by 2. Okay, similarly guys, I can also solve for x. When you solve when you solve for x, don't worry guys, corona YouTube se nahi phailta. Okay, when you solve for, I don't have corona by the way. Okay, don't worry about that as well. Yeah, this is just normal. Anyways, yeah, so when you solve for x also, it can be easily calculated as d minus d by 2. Okay, and these two equations will become very very important. These two equations will become very very important. Please keep a track of that. Okay, keep a track of both these equations. Okay, yeah. I hope you guys understood. Now, guys, in this case, what I will do is I will just take the first case. Okay, I will just take the first case. So let me remove the second case. Let's just remove this and this and this and this and this and this and this. Okay, let me just take the first case. In that first case, guys, if I ask you the value of u, if I ask you the value of u, what will be the value of u? Can you guys tell me what will be the value of u? Will it be plus x or minus x? Will it be plus x or minus x? Plus x or minus x? Yes, plus x or minus x, plus x or minus x, it will be minus x. Okay, and similarly we will be plus 1. Let's say the focal length is f, guys. So what I can write is, I will write in the next page, 1 by v minus 1 by u is equal to 1 by f. Okay, or 1 by y minus 1 by minus x is equal to 1 by f. Minus minus becomes plus. I get 1 by y plus 1 by x is equal to 1 by f, and I know the value of x and y. I will substitute that here. I get 2 divided by d plus d plus 2 divided by d minus d is equal to 1 divided by f. Now guys, from this you can easily calculate the value of f. When you do that, you will get this sum equation, blah 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 4d something something, which gives you something like f is equal to d square minus d square by 4d. Okay, थोड़ा वो हो गया. Let's just cross multiply. If you do, you get f is equal to d square minus d square by 4d. This is the lens displacement method, guys. This is the lens displacement method. I hope you guys understood here. I hope you guys understood. This is the formula for focal length using lens displacement method. Lens displacement method. Okay, I hope everybody understood. I hope everybody understood. Okay, guys. Now, in this case, let's say because I have two different cases. Okay, because I have two different cases, let's talk about magnification of those two cases. Okay, let's talk about magnification of those two cases. This is the second case actually. This is the first case and the second case. Okay, let's say the height of the object is HO. Okay, oh my god. Let's say the height of the object is HO, and here the height of the object is minus H1. Okay. Now, what can I write? I can write H1 divided by HO. The height of the object divided by the height of image divided by height of object is V by U, if you guys remember this. Okay, but in this case, if you substitute it, it will just come out as Y by X. Do you see that? In this case, if you substitute it, it will just come out as Y by X. There will be negative signs and all, but ignore that. We're just talking about the values here, right? Okay. Now, similarly, in the second case, guys, let's say once again, this is still the height of the object and this is the height of the image too. Now, here what I can write is height of the second image divided by height of the object will be equal to what? X divided by y. Will be equal to what? X divided by y. Now, if I compare both of these together and multiply it, if I compare both these together and multiply it, guys, what do I get is, oh my god, it's design ideas, not jaan le lenge meri. What I get is height of image 1 upon height of object into height of image 2 divided by height of object is equal to y by x into x by y. Oh my god, what is y by x into x by y? Oh, oh, I can't think of anything. What will the right hand side become, guys? What will the right hand side become? Right hand side will become just 1, and this gives me the second equation. The height of image 1 into height of image 2 is equal to height of object square. Height of image 1 upon into height of image 2 is equal to height of object square. Guys, I hope you guys understood. I've given you two formulas so far. This is the second formula and this is the first formula. I hope everybody understood. Really hope everybody understood. Okay. Really hope everybody understood. And finally, guys, there is one more thing that you have to remember here. Okay. There is one more thing you have to remember here. Okay. So what I will do is, where is it? Yeah. What I will do is I will just go back to this formula and take a look at it one more time. Okay. Take a look at it one more time. So if I talk about this, f was equal to d square minus d square upon 4d, which if I cross multiply, I get d square minus d square as 4df. And oh my god, 4df, and this can be written as d square plus 4df minus d square is equal to 0. Okay, from this, guys, if I try to solve for small d, from this, if I try to solve for small d, what do I get? If I try to solve for small d, I get a quadratic equation that will be equal to minus 4f plus or minus under root of minus b plus or minus b square. Am I correct? Am I doing everything correct? Am I doing everything correct? Oh, I made a big mistake. Oh my god, I made such a big mistake. I made such a big mistake. Oh, ho, 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 ho. Did I make a mistake? Did I make a mistake? Yeah, I made such a big mistake. Oh my god. Oh my god. Oh my god. Yeah, I made such a big mistake. Can you guys see it? Can you guys see it? Yeah, I made such a big mistake. Ouch. Ouch. This hurts. This hurts. Yeah. This will actually be, guys, this will actually be capital D, okay? This will actually be capital D. Who made a mistake? I. Who made a mistake? I. Yeah, I made such a big mistake. Oh my god, yeah. Please don't go away, okay, guys? It's just a calculation mistake. My physics is still strong, okay? My physics is still very strong, yeah. Okay. Yeah. That's what I'm thinking. What am I getting here? What am I getting here? All this bad equations. Oh, yeah. This is capital D. Okay, this is capital D. Yeah. Okay. So what I get is 4df is equal to d square minus d square, which gives me d square is equal to d square minus 4df. Okay, which finally gives me, guys, d is equal to under root of d into d minus 4f. Do you guys see this? D is equal to under root of D into D minus 4F. I hope you guys can see this. I hope you guys can see this. Okay, yeah, I think everybody saw my mistake, and I think now everybody is back on board again. Okay, now this is where you have to pay very close attention. Okay, very close attention. Pay very close attention. If D is smaller than 4F, if I take D as smaller than 4F, then in that case, what happens, guys? In that case, what happens is I get small d as imaginary. Okay, I get small d as imaginary. Do you guys see that? Do you guys see that? Why will it be imaginary? Why will this be imaginary? Because this number will be negative, so therefore it will be imaginary. I hope you guys can see that. I just had lunch. Okay, I just had lunch. Yes. Now, what that means is that this experiment will not give you any results. You will not be able to perform this experiment. Okay, the thing that you were doing initially, one position, second position, one position, second position, one position, second position, you will not be able to do that if this d is smaller than 4f. You will not be able to do that if this d is smaller than 4f. Okay, because you will not be able to get only any real image. Okay, similarly, if d is equal to 4f, then small d will be equal to 0. If d is equal to 4f, then small d will be equal to 0. Do you know what situation you will get in that case? Do you know what situation you will get in that case? I will show you what you will get in that case. Just give me 1 second. Now let me copy. Yeah, I will show you what situation you will get in that case. You know what will happen? In that case, what you will get is just a lens which is perfectly in the middle, and giving a sharp image. Here d is equal to 4f, so you will get an image when the object is at 2f and the image is at 2f. You will get only one sharp image. Will get only one sharp image. Okay, and finally, if d is greater than 4f, then d is non-zero. Okay, then D is non-zero. Then in oh Tumansh, hi Tumansh. Okay, then in that case, you will have two distinct sharp images. In that case, you will have two distinct sharp images. Okay, I hope you guys understood. If D is smaller than 4F, then in that case, though, it is impossible to do the experiment. Here, there will be no sharp image at all. If D is equal to 4F, I will have one sharp image. And if D is greater than 4F, I will have two sharp image. Okay, I hope guys everybody understood. I really hope everybody understood. If you did, please give me a thumbs up in the chat. Please give me a thumbs up in the chat. Okay, I hope everybody understood. Okay, so basically you have to remember two formulas only. What are the two formulas you need to remember? One is the formula for focal length. This one very important. Okay, and the second formula that you need to remember is height of first image into height of second image is equal to height of object square. This is the second formula that you need to remember. Just if you remember these two formulas and didn't understand anything, that's also okay. But you know what? Understanding this is fun. That's why I taught you this. Okay, so here's a question for you guys. Please tell me the answer in the chat. Okay, please tell me the answer in the chat. Okay. Please tell me the answer in the chat. La, 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 la. See, this looks like a very hard question unless you understand this diagram. Okay, if you can remember this diagram, things will become very easy. If you can just remember this diagram, things will become very easy. Okay, so try to solve this question. Try to solve this question. Tumansh, you got a rank of 131913. So that means Tumansh, you are appearing for that, right? Tumansh is appearing for advanced. Yes. Pranati every day, not alternate days. Okay, after the advance every day, not alternate days. I want to go back to that everyday schedule. Seriously. Huh. So guys, in this case, what do you do? What do you do? What do you do here? What you can say is here, what you can say is that okay, let's say this is my object, this is the lens. Oh my god, this is the lens. Okay, and this is the image. Okay, the magnification, if this distance is x and if this distance is y, I can write the magnification as y divided by x. Okay, also at the same time, I don't know if you guys know this, but the next time the lens goes in this direction, it moves by a distance d and this entire distance becomes y. So one more thing that I can write here is that d is equal to y minus x. B is equal to y minus x. I hope you guys can see this. I hope you guys can see this. Okay, now based on this, guys, based on this, one second, go and go, go. So based on this, I can first calculate the value of x and y. Okay, so I can write xm is equal to y, which I will substitute in the second equation, mx minus x, which gives me x is equal to d by m minus 1. Similarly, I can write y is equal to, md upon m minus 1. md upon m minus 1. I hope you guys understood. Really hope you guys understood. Okay, now guys, what I can use this for is I can say next that the object distance is equal to, oh my god, हाँ, the object नहीं होगा, नहीं होगा. Yeah, draw with touch. Yeah, object distance is equal to minus x, image distance is equal to plus y, and 1 by v minus 1 by u is equal to 1 by x, 1 by f. Okay, substituting all of these into a new slide. Okay, substituting all of these. What is happening here? Yeah, substituting all of this into a new slide. 1 by v minus 1 by u is equal to 1 by f, or 1 by y minus 1 by minus x is equal to 1 by f, or m minus 1 by md plus m minus 1 by d is equal to 1 by f. Okay, now do you guys know how to solve this? Do you guys know how to solve this? I think you guys know. I think you guys know. How do we solve this, guys? We have to take LCM of both. Okay, we have to take LCM of both. So what I will say is 1 by f is equal to 1 in this md, and this will be m minus 1 plus m times m minus 1. Okay, which gives me 1 by f is equal to, in the denominator, md, in the numerator m minus 1 plus m square minus m. This m and m will get cancelled out, and I will get finally f is equal to, I will get finally f is equal to md upon m square minus 1. Okay, guys, I hope everybody understood. Okay, Atharva Sharma knows this formula. Oh, I didn't know Atharva Sharma knew this formula. Okay, but I hope everybody understood. Girek is asking, sir, how much rank is needed to get into IIT Bombay? Girek, that's a very good question. How much rank is needed to get into IIT Bombay? That depends, my friend, on which branch you want. Okay, if you want computer science branch, then get a rank of under 50. If you want another branch, like let's say you want a branch of metallurgical science and that engineering or whatever, that will go to lower rank as well. Okay, but overall, I would suggest get a rank of below 2000 to get a good branch, a decent branch at least. Okay, otherwise I would suggest don't go to IIT Bombay in that case, go to other IITs in that case. Okay. Huh. Sam Niran is asking, sir, is there any other formula for focus? No, Sam, there are, for not in this case, Sam. In this case, because the question asks us the formula in terms of m, so that's why I'm going to write it like this. Okay, in this case, the question asks us the formula in terms of m. Otherwise, this. Yeah, Atharva Sharma is saying get All India rank 1. Atharva Sharma, I love your hopefulness. I love your, I mean, it's definitely possible for you to get rank 1, but also at the same time there is only going to be one person in the India who will get rank 1. Okay, your aim should be to get into top 50. Rank 1 is, yeah. Very good. Yeah, you should aim for that. You should aim for that. Aim always high. Okay, aim always high. Yeah. Manasa is asking, sir, what is the next topic? Manasa, the next topic is going to be, very, very much dependent on what you guys want. There will be a poll very, very soon, and we will ask you in that poll which topic you want us to do next. Okay, I'll give you the options right now. It's going to be either wave optics or electrostatics or current electricity. Okay, there's also a chance of capacitance if you want that. So one of those topics, if you want, I will do that. I will not start with modern physics right now. It's either wave optics or chapters from book 1. Okay, it depends on what. Yeah. No, in this case, though, Sam, you have to calculate the answer in terms of what is given in the options, right? You have to talk in terms of what is given in the option. The options, it's md upon m square minus 1, so I just use this. Okay, alright, guys. So wave optics. Pranati wants wave optics. We'll probably start with wave optics. I don't know. It depends on your votes. Okay. Hmm. It should actually be votes of people who are coming to this class rather than everybody on Telegram, but you know what, I don't know. So you know what, vote on the comments. Okay, vote on today's comments and tell me which chapter you want me to do next. You guys have to decide which chapter you want me to do next. I don't want to ask on Telegram. Telegram pe koi bhi jawab de deta hai. You guys who are attending my class, you decide which chapter you want me to do next. Okay, so write in the comments, write in the comments. That way I will know. Okay, I can put a poll on, but poll कोई भी answer कर देता है ना. That's the problem, Sam. Anybody can answer on a poll. I want people who are watching this video to answer. Okay. Anyways, so let's talk about next different important points of lens. Okay, the lens has something called an optical center, and what we say is that whenever a light ray passes from optical center, it goes in a straight line without deviating. This is not exactly true if your lens is thick. Okay, if your lens is thick, this is what essentially happens. If your lens is thick, this is what essentially happens. The lens gets displaced by a small amount. The ray gets displaced by a small amount. Okay, but if you have a thin lens, then the incident and the emergent ray are almost in the same direction. Then the incident ray and the emergent ray are almost in the same direction. Okay, I hope everybody understood. Really hope everybody understood. Okay, now in case of lenses, there are two focuses, and both of them have different definitions. Okay, first is called the first principal focus. Here you have to remember that the rays are finally parallel. Here the rays are finally parallel. Okay, here after refraction the rays are parallel. After refraction the rays are parallel. Then in that case, the point from which they are coming, either this point, they are coming from this point, or they appear to be incident at this point. Then those 2 points are called principal focus, the first principal focus. Okay, here in case of the second principal focus, you have to remember that rays are initially parallel. Then after refraction, wherever they meet is called the second principal focus. If after refraction, wherever they meet is called the second principal focus. Is called the second principal focus. Now, if you guys remember this, let me ask you a simple question, guys. Let me ask you a very simple question. Okay, if I have this one, okay, I don't know which lens is this, and I have this focus. Okay, let's call it, yeah. So now this F is which one? This is the first one or the second principal focus? Is the first principal focus or the second principal focus? Tell me in the comments, guys. Tell me in the comments. This F is what? The first principal focus or second principal focus? Uh, First or second? First or second? Hmm. Okay, first to second. This is, by the way, guys, the second principal focus. Sorry, I forgot. Yeah, this is the second principal focus. Okay, just remember these diagrams, guys. You just have to remember this. यहाँ पर it's just nomenclature in general. See, my name is Aditya. Atharva's name is Abhyuday. Sam's name is Sam. I can't just ask you the reason, right? Like, why is your name Sam? Tell me why your name is Sam. So there's no reason for that. It's just the name. Everybody decided that is going to be your name, and you just have to remember it. Okay, similarly, this is the first principal focus. Everybody decided that this is what we will call for first principal focus. You just have to remember it. Okay, this will be the second one. You again have to remember it. In case of concave, it's the opposite. In case of concave, it's the opposite. Okay, anyways, guys, so let's talk about combination of lenses. Okay, let's talk about combination of lenses. Now, guys, this is very low. If you want, I can give you the proof for the first one. For the second one, I'm not going to give you the proof because it will take me half an hour just to. It will take me half an hour just to do the proof. Okay, the second one, it will take me half an hour just to do the proof. So I will not be doing that. The first one, you have to remember, if I have two lenses very close together, then the equivalent focal length is 1 by f1 plus 1 by f2. The equivalent focal length 1 by f is 1 by f1 plus 1 by f2. I hope you guys will remember this. I hope you guys will remember this. Now, if I have two lenses at a distance apart from each other, then here the formula is, one second. Now, one second. Let me just remove a little bit. Let me just remove it. Here the formula A999. Here the formula is go away and draw and go away. You as well. Here the formula is 1 by f is equal to 1 by f1 plus 1 by f2 minus d by f1 f2. Okay, now the formula for the second one is very weird. Okay, it comes after a lot of derivations, so I will not prove that. The first one also is simple. I will prove the first one very simply. Okay, I'll prove the first one very simply. Okay, how do I prove the first one very simply, guys? How do I prove the first one very simply? So let me do that. Go this and this. Okay, so what do I do, guys? What do I do first? What I do is, let's say I have a lens here of focal length f, and I keep an object here. Okay, and because of that object I have an image somewhere here. So what equation can I write? 1 by v, okay, minus 1 by u is equal to 1 by f. Now I don't want to call this image distance as v. I will call this image distance as v dash. Okay, I want to call it image distance as v dash. Now what happens if I add a second lens, guys? What happens if I add a second lens? If I add a second lens, then for that lens this will become the object. For that lens this will become the object. And for that, if I write down the formula, I will write 1 by v, the final image distance, minus 1 by v dash, because this is going to be the object distance for the second one, is equal to 1 by f2. Okay, now in this case, if we add the two, I will get 1 by v minus 1 by u is equal to 1 by f1 plus 1 by f2. Okay, I hope you guys understood. Everybody understood. Okay, now Surinder, hi. We only the क्या हुआ यहाँ पे कुछ doubt चल रहा है क्या? Okay, okay. There are people. Samniran, you did not draw the rays and how to find which part you are talking about. I don't understand. Which part are you talking about? Okay. Yeah, Samniran is asking, sir, which part are you talking about? Yeah, that is true, Samniran. That's a very good point. Guys, Samniran is right. This is the second focus. Only if your incident rays are coming like this. Okay, only if your incident rays are coming like this. Okay, if your incident rays are traveling like this, then this will be called second focus. Okay, if your incident rays are, then it will be called first focus. Depends on incident ray direction as well. If incident rays are coming like this, then this will be a second focus, and if incident rays are starting from here, then it will be the first focus. Okay, yeah, very good. Yeah, Samniran, you are exactly right. Yeah, sorry, guys, sorry. That's my mistake. Okay, all right, guys. Now, if you understood so far, let's go to the next question. Okay, now this question might seem a little bit hard, but it's not exactly. Okay, and I'll give you 2 minutes to solve this question. All right. So, how to solve this question, guys? How to solve this question? Yeah, I'll give you one small hint. Okay, it is a combination of three different lenses: the first lens, the second lens, and the third lens. Okay, and you know the radius of curvature everywhere: 10, 10, 10, 10, and 10 and 10. And you know the material of the lenses as well, the refractive index of the material of lenses as well. 1.5, 4 by 3, 1.5. Okay. And finally, what you have is the medium surroundings. Okay, what will be the refractive index of the surrounding medium? So here the surrounding medium will have refractive index 1 and 1. What will be the refractive index of the surrounding in the second lens? What will be the refractive index of the surrounding in the second lens? What will be the refractive index of the surrounding in the second lens? I will give you two options, guys. Okay, if this is 1 and 1, what will be the refractive index here? 1 or 1.5? What will be the surrounding medium refractive index in the second case? 1 or 1.5? Tell me in the chat, guys. Tell me in the chat. Yes, Sri Balaji, we will do. We will do. Before we start the next chapter, we will do, my friend. We will do. We will do. What will that be? Surinder is saying 1.5. Muthu is saying 1.5. And guys, this is where many of you will make mistakes. Remember this. When you have combination of a lot of lenses, then this lens is basically, you don't have to consider this lens in between these two lenses. You have to consider its surrounding as this medium only. What I mean is the surrounding medium has refractive index 1 only. The surrounding medium is the same for all three lenses. The surrounding medium is same for all the three lenses. Okay, it doesn't matter what is there in between. There might be a few lenses here and here. You always ignore them and you just go right to the surrounding medium. Okay, basically when you're looking at this lens, you ignore the two surrounding lenses altogether. Okay, and the surrounding medium will be 1 in 1. Yeah, Shri Balaji is saying very right. But sir, it is in the center. And Shri Balaji, you are right. It is in the center. Okay, but if you try to derive, see, don't think about it like this. Right now, the distance between the three lenses is exactly 0. Okay, you don't have to think of the three lenses as kept at 0 distance. You rather have to think of them as kept at very small distance. Okay, think of all the three lenses like this. Oh my god. Okay, think of all the three lenses like this. One here, okay, the other one very close by but not exactly stuck to it, and the third one also very close by but not exactly stuck to it. Okay, always think of the three lenses like this. Okay, and in that case, the surrounding mediums will be equal to what? The surrounding medium will be same for all of them. It will be air only. Okay, it will be air only. Sam Niran, do you understand? Yes. Sri Balaji, do you understand? Yes. Sam Niran already understood. Sri Balaji, did you understand? Okay. I hope so, guys. I hope everybody understood. So now, based on this, guys, based on this, you have to calculate the focal length. Okay, so let me try to calculate the focal length. First, let me delete this. Okay, so focal length of all the three. Let's try to calculate. Okay, the first one, let's say focal length is f1. How will I calculate f1? I will write 1 by f1 is equal to 1.5 by 1 minus 1 into, with proper signs you have to write R1 and R2. Okay, with proper signs you have to write R1 and R2. Let's say an incident ray is coming in this direction. Then R1 will be negative and R2 will be positive. R1 will be negative and R2 will be positive. So you will write 1 by minus 10 minus 1 by plus 10. Okay, this gives you 0.5 into minus 2 by 10, which gives me f1 as minus 10. Okay, which gives me f1 as minus 10. I hope you guys understood. Really hope you guys understood. Similarly, guys, you can also calculate f2. f2 के लिए this is 1 and 1 and 4 by 3 and 10 and 10. Okay, let's say the incident ray is coming in this direction, then R1 will be positive, R2 will be negative. Okay, so I will write 1 by F2 is equal to 4 by 3 by 1 minus 1 into 1 by 10 minus 1 by minus 10, which if you calculate you will get 1 by f2 as equal to 1 by f2 as equal to 330, yeah, and 2 by 30, okay, or 1 by 50, 2 by 30 or 1 by 50. Okay, I hope you guys can see this. I hope you guys can see this. Okay, now if you have three lenses and this has focal length of -10, this has focal length of +15, the third one will still have focal length of minus. Okay, now I will write the equivalent focal length as 1 by -10 plus 1 by 15 plus 1 by -10. Okay, that will be equal to minus 3 by 30 plus 2 by 30 minus 3 by 30. That will be equal to minus 4 by 30, which gives me f is equal to minus 7.5 centimeters. Okay, I hope you guys are following, guys. I really hope you guys are following. I really hope you guys are following. It's very, very simple here. You just have to add. Okay, yeah, minus 15 by 2 minus 7. Okay, guys. So if you understood so far, superb, superb, superb. Let me tell you one more time. If you're a repeater and you want to get onto Vedantu's platform and you want to study in the next 4 months very properly, then we have faculty from Alan Chandigarh. They have just started a batch on 21st September. They are going to start one more batch very, very soon. And if you go through the link below and use my coupon code AAPPRO, guys, you will get 20% discount. You will get 20% discount. Instead of 7,500 a month, you will get it at 6,000 a month. Okay, please go through the link in the description and check it out. Check it out. Check it out. All right, guys. So I will stop here. I will stop here after I give you a homework question. If you have any doubts, guys, you can ask me the doubts in the comment section, or you can ask me the doubts on my Telegram ID, which, if you don't know, my Telegram ID is at AAP, sorry, AADITYAP832. Okay, you can ask me your doubts on Telegram ID, and this is the homework question. Please answer in comments. Alright guys, I hope everybody understood. I am going to upload the notes very, very soon, and I will see you guys on Monday. I will see you guys on Monday. Okay, have a nice day guys. Bye bye. Have a nice day. Bye. Bye. Bye 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 bye. Oh, you can't see this. Yeah, answer to this question.